Hey everyone, and welcome to this explainer. Look, I know the second you hear the words welding codes, it's easy to just roll your eyes and think of endless, boring, bureaucratic red tape. But today, we're going to flip that script. We're taking that alphabet soup of acronyms, WPS, PQR, WPQ, and breaking down how they are actually highly practical, life-saving procedures. If you've ever felt a bit lost when staring down joint preparation under strict standards like ASME Section 9, you are in the perfect place. Today is all about understanding how these codes provide the ultimate recipe for your work, right down to the essential variables like thickness and base metal. So let's jump right in.
Okay, just take a look at this. Codes are not paperwork. They are lessons written in blood. I mean, wow, right? That powerful statement really sets the absolute highest stakes for what we're talking about today. It's so easy to just toss a thick binder of regulations into the corner of the shop. But a bad weld? That isn't just an oops moment. A bad weld means catastrophic failure. When massive pressure vessels fail, people literally lose their lives. These codes only exist because, historically, the alternative was absolute tragedy.
So here is our roadmap for this explainer. We're going to quickly cover why these codes matter. Look at the two main ones. Dive deep into why your WPS is your master recipe, break down those all-important essential variables, look at the testing process, and finally, go over how you actually keep your qualification alive. All right, Section 1, Why Welding Codes Matter. Picture this. Back in the 1800s, right in the thick of the Industrial Revolution, boiler explosions were just a terrifyingly common thing. Hundreds of people were killed simply because there was no standardized way to verify the metal joints holding back all that immense pressure. That specific massive danger is exactly why ASME, the American Society of Mechanical Engineers, was born in the first place. But hey, today, following these codes does way more than just stop explosions. It actually protects you. If you follow the code to the absolute letter and a weld fails way down the line, you're not to blame. The procedure is. Plus, let's be real, clients trust a coded welder. Getting the job done right, strictly under code, means more jobs and better pay. It's a total win-win.
Moving right along to Section 2, the two main welding codes.
At the end of the day, both of these frameworks are just trying to keep people safe, They just use slightly different dialects to get the job done. ASME Section 9 is the absolute heavy hitter globally, especially when we're talking about pressure vessels. It organizes base metals using P numbers and filler metals using F numbers. On the flip side, ISO 9606-1 is super common for general welding internationally, relying on material groups and FM groups. For this explainer, though, we are going heavily into ASME Section 9 because its strict P-number system completely dictates how you approach joint preparation. If you're on an ASME job, you are going to be living, breathing, and sleeping those P numbers. Which brings us nicely to Section 3. The WPS is your recipe. Guys, this is absolutely crucial. The WPS, the Welding Procedure Specification, is literally your master recipe. Think of it like baking a cake, except this cake is heavy, made of metal, and might hold back explosive pressure. The WPS tells you exactly how to execute the weld. Your process, your filler metal, your electrical current, preheat, position, it's all in there. When you are doing joint preparation according to ASME IX, this document is your Bible. You don't just look at two thick plates of steel and guess the bevel angle or wing the root gap. No way. You always check the WPS first, ensuring your joint prep aligns perfectly with that approved engineering recipe. So if the WPS is your recipe, the PQR, the Procedure Qualification Record, is the ultimate, foolproof taste test. It's the hard proof that the recipe actually works in reality. Long before a WPS is ever handed you on a job site, a test weld was done. They took that weld and basically tortured it with intense bend and tensile tests. Once it survives all that, the PQR is filed away. And the really cool thing about a PQR, it lives forever. It never expires. It's the permanent foundation proving your joint prep and welding parameters are completely safe. And finally, we have the WPQ, the Welder Performance Qualification. This one is all about you. This is your personal golden ticket, proving that your specific hands can successfully follow that WPS recipe. Your actual name is on this document. It outlines the exact process, the position, base metal type, and thickness range you're legally qualified for. The WPS proves the science is sound, but the WPQ proves you've got the skills to pull it off.
All right, let's jump into Section 4, Essential Variables and Ingredients.
Okay, so what happens if we want to tweak our recipe? Well, these essential variables are the strict, unbreakable rules of ASME 9. If you change even one of these, you have to completely retest. There are zero shortcuts here. Take base metal, for instance. If your WPS says carbon steel and you randomly switch to stainless, bam, new test required. And thickness? Thickness is a massive one for joint preparation. If the thickness falls outside your qualified range, you need a new test because thickness totally changes how heat dissipates, which completely alters your required joint profile and penetration. Even just swapping your process from stick to MIG throws the whole recipe out the window.
Let's pivot over to Section 5, Testing and Licensing Welders. I love this flowchart because it perfectly separates the procedure lane from the welder lane. It's all about proving the recipe works before we ever test the person. First up, engineers write the WPS. Second, they do a test weld to generate the PQR, proving it survives the bend and tensile tests. Okay, recipe approved. Now we cross over to the welder lane. You weld a test coupon, like a pipe or a plate, following that exact WPS. Then your specific weld gets hit with a visual and bend test or maybe an X-ray. You pass? Boom, your WPQ is issued and you're making money. You fail? It's back to training and you usually gotta wait 24 hours to try again. It is a highly controlled pipeline.
Almost at the finish line. Section 6, Keeping Your Qualification Alive. So you earned your qualification. Awesome. But you can't just put it in a drawer and forget about it. Under ASME Section 9, you must weld using your specific qualified process at least once every 6 months. And listen to me on this, your employer has to keep a log of it. If there's no log, it didn't happen, and you're heading back for a retest. ISO 9600 is slightly different, giving you a 2-year validity, but the core idea is the same. Take this seriously, guys. If your qualification expires and you strike an arc on a coded job, that is strictly illegal, and your employer could literally lose their entire certification. Okay, time for a quick check to see if we're all on the same page. Think back to what we just covered about the ingredients in our master recipe. You're working on the exact same joint prep, but you decide to swap your stick welder out for a MIG setup. Do you need a new test? And more importantly, why? The answer is an absolute yes, because the welding process itself is an essential variable, making that substitution totally ruins the established recipe. Under ASME codes, a completely new test is mandatory. You just can't carry qualifications over between different processes. Let's try one more. Say your welder performance qualification was last used and officially logged 7 months ago under ASME Section I. Tomorrow, you've got a brand new coded job. What do you have to do? Yeah, you gotta retest. You literally missed the 6-month rule window by just 1 month. This right here is exactly why hounding your supervisor about logging your work is critical for your career. You do not want to be benched on a high-paying job just because someone forgot to sign off on a weld you did 5 months ago. Stay on top of your paperwork. Wow, we have covered a ton of ground today. We went from the tragic boiler explosions that forced these codes into existence, straight through to how your WPS dictates your exact joint preparation, and right down to the nitty-gritty essential variables like thickness and base metals. So, I'll leave you with this. The next time you step up to prep a joint and get ready to weld, I want you to ask yourself, are you just blindly striking an arc, or are you executing a precise, blood-tested recipe that guarantees everyone gets to go home safely to their families tonight? Thanks so much for hanging out with me for this explainer, and keep that arc steady.